2 moles. (294 joules of heat). So amount of heat supplied is 294 joules. To raise the temperature of 2 moles of ideal gas from 30 degree to 35. So change in temperature is 5 degrees Celsius. At constant pressure, the specific heat of gas at constant pressure will be how much if R is 8.4 joules per mole degree Kelvin. Heat supplied at constant pressure is equals to N times, कौन सा गैस है जरा देख लो, ऐसा नाम दिया है नहीं, खाली बोला आइडियल गैस, heat supplied at constant pressure. Total heat supplied at constant pressure is N times Cp dt. So 294 is heat, number of mole 2, Cp I don't know, dt is given 5. dt is 5. Therefore 294 upon 10 equal to Cp. So Cp equals to 29.4 joule per mole Kelvin. That is option number C. C is the option. Write down solution. Too fast. Today I have to complete, and if time is there, start with thermodynamics. Done?
Yes, sir.
98. It is continuation of 97. In the above question, amount of heat required to raise the temperature of same gas through same range but at constant volume. So to get heat supplied at constant volume, same formula, it is N, but Cp will become Cv into dt. Since Cp minus Cv is R, Cp we got 29.4, Cv I don't know, R is given 8.4. 29.4 minus 8.4 is Cv, therefore 21 equals to Cv. So heat supplied at constant volume is N, N means 2, Cv is 21, dt is same temperature 5, which is 210 joules. So A option 210. Solve. And if completed, please let me know.
Done, sir.
99. Following sets of CVCP are observed, are reported by different students. The unit is in calorie, gram per gram mole Kelvin. Which of the following set is reliable? See, CV is given 3, CP is given 5. That means here CP is greater than CV. बराबर है. Difference of CP and CV is R. So Cp minus Cv, we will check whether it is R or not. Cp बड़ा चाहिए, difference R चाहिए. Cp का value is 8.4 in terms of joules per mole Kelvin, but they have given in calorie. So for calorie, we'll divide by 4.2. This becomes calories per gram mole Kelvin. So 2. That means Cp minus Cv should be 2 in CGS unit and Cp should be bada. So first wala Cp 5, Cv 3, matlab Cp bada. Also Cp minus Cv equal to R, which is 2, match ho gaya. So A is the required option. If you check others one, Cv bada nahi chalega. Then third mein Cp 5, 4 minus 1 nahi chalega. So A is the correct option. Any doubt in understanding this first 99? हेलो
No, sir.
अब ये याद रखो, अगर यूनिट सबका सेम नहीं है तो वी डिवाइड दैट क्वांटिटी बाय जे विच इज इन जूल. आर का यूनिट बोला है कैलोरी. कैलोरी इज नॉट इन एसआई यूनिट, देयरफॉर आई डिवाइडेड बाय 4.2. इट शुड बी इन जूल यूनिट. कंप्लीट 99 फास्ट.
Yes, sir.
100. The amount of heat required to raise the temperature of 1 gram mole. 1 gram mole. N equals to 1 gram mole of a monoatomic gas by 1 Kelvin. By 1 Kelvin. Keeping the volume constant in calorie. Amount of heat required to raise the temperature of 1 mole of monoatomic. This word is important, monoatomic. Because mono, di, poly का मुझे CpCv मालूम रहता है, so I should know which type of gas to get the answers. Now, gas is heated at constant volume. So for monoatomic gas, at constant volume for monoatomic gas, Cv equals to 3/2 R. Therefore, heat supplied at constant volume is N Cv dt. N is 1, Cv is 3/2 R, dt is also 1. So this becomes 1.5 R, which is given in A. Sorry. And
Sorry.
this monodite and polyca CpCv you have to remember.
Yes, sir. Done.
Here? Okay. Next one. Dimensions of specific heat are. Now first I should know what is specific heat. We have already done. Then once I know its formula, then only I can find dimension. This specific heat comes in formula of heat. Total heat is mass into specific heat into change in temperature. So specific heat is Q upon M theta. Q is heat, heat is energy, and energy का dimension is M1 L2 T minus 2. Mass dimension is M1. Temperature is K1. So we get M0 L2 T minus 2 K minus 1, dimension of specific heat. M0 L2 T minus 2 K1 is in option D. M is not present means M raised to 0. So option D. Any doubt? Hello, 101, any doubt? Is there?
No, sir.
Please copy. This Friday you will have, Thursday you will have test on MCQ of KTG and radiation. Done?
हाँ सर हो गया.
Okay. Some बहुत अच्छे. 102. A monoatomic gas. इशिका?
हाँ
हेलो?
सर.
जैसे आपको ये मोनोएटॉमिक गैस दिखता है तो आपको इसका सीपीसीवी क्लिक होता है क्या? क्या है सीपीसीवी इसका?
नहीं ऐसे तो अभी तो नहीं है.
इसका याद रखना, ये 5/2 आ रहा है और ये 3/2 आ रहा है, ये याद होना बहुत जरूरी है आपको. सीपीसीवी और ऑफ मोनो, डाई रिजिड, डाई नॉन रिजिड एंड पॉलीएटॉमिक. So once I read monoatomic, मुझे क्लिक हो जाता है Cp और Cv का वैल्यू. Whether it is mono, whether it is di, whether it is tri, whether it is poly, Cp minus Cv हमेशा R रहने वाला है, ये फिक्स है. इसको मेयर्स रिलेशन बोलते हैं, फिक्स है. But ratio will be different for different types of gas. A monoatomic gas expands at constant pressure on heating. The percentage of heat that increases the internal energy of gas and that is involved in expansion will be respectively how much? बहुत सही समय. If gas is heated at constant pressure, then what percentage is increasing internal energy and what percentage is increasing the is involved in expansion? This we have to calculate. इसका मतलब क्या है? Cp molar specific heat at constant pressure is at constant volume. Now I know gamma is Cp upon Cv, which will be here 5/3. Any doubt till this?
No sir.
No, sir.
We are interested in what percentage is internal and what is work done. Heat supplied at constant volume only increases internal energy. I am writing U. But at constant pressure, it is increasing internal energy and also doing work. मतलब अगर total heat 5 दिया तो उसमें से work done will become 2 and internal is 3. This is the meaning. So 5 I can write as 3 plus 2 and 3 is 3. तो पूरा 5 part में, that means from 5 part, 3 part is internal energy. So percentage change in internal energy, total heat supplied at constant pressure is 5, then out of that 3 part is internal, percentage multiplied by 100, 5 into 20 equal to 60%. Work done is equals to, out of 5, 2 into 100 equals to 5 into 20, 40%. So work done will be 40% and internal energy is 60%. Method is, whenever you get CP, CV, if they give then okay, otherwise नाम दिया है तो याद रखना पड़ेगा. So CP मतलब total heat supplied, CV मतलब heat supplied to increase only internal energy. Convert this numerator as internal plus work. Internal denominator से समझ जाएगा. So 3 plus 2 upon 3. Therefore, increase in internal we got and work done we got. Out of 5, 3 is internal. Out of 5, 2 is work done. Hello? Hello?
हाँ
So this is the required answer. 60% is internal and 40% is work done. इधर दिया ये internal energy first पूछा है ना, तो C is the answer. 60 is internal, 40 work done. Everybody has followed or any of you have doubt in this?
follow sir.
Okay. Done?
हाँ sir.
Okay, everybody is done? Anushka?
Yes, sir.
103. On giving equal amount of heat at constant volume, equal amount of heat at constant volume to 1 mole of monoatomic gas and diatomic gas. The rise in temperature is more for mono, more for di, or same. So amount of heat supplied at constant volume for monoatomic gas is same amount of heat supplied for diatomic gas. Even we'll always take diatomic rigid gas. Now this is N times Cv for monoatomic gas into rise in temperature of monoatomic. This is N Cv for diatomic into rise in temperature of diatomic. Mole is same, will get cancelled. Cv for monoatomic is 3 by 2R and Cv for diatomic is 5 by 2R. Both sides is R by 2 cancel. So monoatomic will be 5 by 3 times diatomic. Now clearly I can say 5 by 3 is greater than 1. So D of mono is greater than D of diatomic. More for monatomic is given in option A. This is the required answer. Solve.
Done, sir.
Latent heat of vaporization of substance is always what? What is meaning of latent heat? 11th का topic actually. Latent heat. The amount of heat absorbed by unit mass of substance. Amount of heat absorbed by unit mass of substance to change its state at constant temperature is called as latent heat. Amount of heat absorbed by unit mass of substance to change its state at constant temperature is called as latent heat. That means if L is the latent heat and M is the mass, then total heat required will be ml. So latent heat is heat per unit mass. Its SI unit will be joule per kg. फिर बोला latent heat of vaporization ज्यादा है relations. If the substance is getting converted into vapor, that means it is changing from solid to liquid and then gas. So definitely ज्यादा heat लगेगा. मतलब Q will be greatest in vaporization. So latent heat of vaporization will be always greater than latent heat of fusion. जरा मैं आपको खाली water के लिए value दे देता हूँ थोड़ा, so that you remember two values for water. Latent heat of fusion of ice is equals to 80 kilocalorie per kg. Latent heat of vaporization of steam equals to 540 kilocalorie per kg. So these two values are for water. Ice के लिए 80, vapor के लिए 540. From this also we can judge 540 is greater. So latent heat of vaporization of substance is always greater than latent heat of fusion. B option. पूरा लिख के definition, then write this. Write everything properly.
Done, sir.
Okay. Everybody is done, no? Aryan Patil?
हाँ सर हो गया
105. The amount of heat absorbed by unit mass of substance during the change of state, अभी बताया, it is called latent heat. Amount of heat absorbed during change of state is called latent heat. So 105 का C. 106. Mass of 1 gram of water having volume of 1 centimeter cube on vaporization at atmospheric pressure becomes 16771 centimeter of steam. Heat of vaporization, latent heat of vaporization is 540 calories per gram. The increase in internal energy. Increase in internal energy is called internal latent heat. So just remember, for 1 gram of water, external latent heat is always 40. So internal plus external is called total latent heat. Internal matlab the heat which is separating the molecule. External means because it is expanding, so it has to do work during expansion against external atmospheric pressure. So suppose this is solid, पहला ये molecule का बीच का distance will increase. So this is called internal latent heat. Then because molecule का बीच का distance is increasing, it is expanding. If it is expanding, pressure will not allow it to expand. So it will spend its energy during expansion against external atmospheric pressure. Now volume ka change I can calculate. So always first we find external latent heat. Then if total is given, we can find internal. Here they want internal. I said we can remember for water it is 40. So suppose we are not remembering, by calculation we'll see. तो पहले मैंने ऐसे ही बोला कि अगर याद है 40 तो अपना आंसर हो जाएगा 500 as internal. So 540 is internal plus external 40, that is equals to 500. This is internal. 500 pi option? No, 500 calories. This is without calculation, by remembering. Now with calculation we'll see. First, external latent heat मतलब work done. Work done का unit होता है joule. This is given in calorie, so I will divide by J. So this is pressure into change in volume upon J. Pressure is 1 atmosphere. All units are CGS. So it is 10 raised to 5 dyne 10 raised to 5 Newton per meter square. We have to convert at the end everything in erg because this is in CGS unit. So 10 raised to 5 Newton per meter square is pressure, 1 atmosphere. dV is 1671 minus 1 centimeter cube upon J is 4.2 joules per calorie. So this joule wala I will convert into erg first. So this becomes, see I will in exam remember value. अब पहले इधर तक करो.
डन सर।
अभी ये सब न्यूटन को ऊपर वाला मैं सीजीएस कर देता हूँ. सो 10⁵ 1 न्यूटन. तो ये मालूम है ना, प्रेशर का वैल्यू होता है 1.013 इंटू 10⁵ इन एसआई. तो मैंने खाली 10⁵ लिया, ये 1.03 को निकले. नाउ न्यूटन टू डाइन इज 10⁵. Meter to centimeter will become 10⁴ into 1670 in centimeter cube upon 4.2. So this equals to 10⁵ 10 upon 4 will become 10⁶ 10⁶ into 1670 upon 4.2. This is in Earth, whole thing, into 10⁻⁻7 किया तो it becomes joules per calorie. So this is equals to 167 upon 4.2 joules per calorie. This is nearly 40 joules per calorie. So this is LE external, which I told here 40. So once you get this LE 40, then LI same method say you have to calculate. Copy till this, but please remember in the exam for 1 gram of water it is nothing but 40. Unit was dangerous, that to be converted properly. Done? Bit fast? Done ना?
हाँ सर।
ठीक है, नेक्स्ट करते हैं. 107. In the equation PV equals to RT. Very good. V stands for volume of any amount of gas, 1 gram of gas, 1 gram molecule of gas, 1 liter of gas. You take 1 minute, predict your answer.
Sir, can you repeat? One.
Question you don't have in front of you.
Sir.
In the equation PV equal to RT, then V stands for what? Volume of gas. Any amount, 1 gram, 1 liter, 1 gram molecule.
One gram of water having volume. So 1 gram of 1 gram molecule of gas.
Let others also tell something. Anushka, what volume of gas? Yes, Anushka, what volume of gas is this? Pratham? Hello, Pratham? Pratham?
Sir, Pratham is not in the group.
मैं था ना अभी तो, देखा आया था वो, आपको लगता है निकल गया था? प्रथम आया था, मैंने उसको एंट्री दिया था. PV equals to RT. I know one thing, it is nothing but 1 mole fella. Since PV means nRT, so here n equal to 1. So PV in PV equals to RT, V equals to volume for 1 mole. इतना मुझे मालूम है, 1 mole of gas. पर ऑप्शन में 1 mole है ही नहीं. इतना समझा आप लोगों को? स्टैंडर्ड मेथड PV is nRT, RT दिया है मतलब N1, तो V is volume for 1 mole. अभी 1 mole मतलब क्या? It is given weight upon molecular weight.
Yes.
अभी depending upon कौन सा गैस है, number of molecule will keep on changing. So it is any amount of gas, number नहीं, any mass of gas. Suppose it is oxygen, तो 32 ग्राम लेना पड़ेगा for oxygen. ये अगर हाइड्रोजन होता तो 1 मोल के लिए मुझे 2 ग्राम ही चलेगा. तो any amount of gas ही आंसर है, any amount. V is volume of 1 mole of gas, that is any amount of gas. Very important, generally we write 1 gram more is the answer. Generally we may write 1 gram more. So PV nRT means 1 mole के लिए 1 mole में कुछ भी वजन हो सकता है depending upon type of gas. Clear?
Yes, sir.
Next sum 108. At pressure P and absolute temperature T, mass M of ideal gas fills closed container of volume V. An additional mass 2m of same gas is introduced. So additional mass 2m is introduced. So नया वाला m plus 2m extra into the container, and the volume becomes V by 3. And temperature becomes T by 3. Then pressure becomes how much? First pressure P, temperature is T, mass small m is filled in a closed container, whose volume is V. Then we put extra mass 2m of the same gas into the container, and volume, and thus the volume becomes V by 3, temperature T by 3, and pressure becomes how much? जब भी गैस में इतना कंडीशन दिखा तो एक ही फॉर्मूला है अपने पास, P V is N RT. N means given weight upon molecular weight into RT. Same gas का molecular weight same रहता है. So first pressure P1, second pressure P2, first volume V1, second volume V2, first mass M1, second mass M2, first temperature T1, second temperature T2. First pressure P1 is P, P2 we want to find. This P2 we want to find. Volume is V, new volume V by 3. First mass M, second mass 3M. First temperature T, second temperature T by 3. T, MM cancel, VV cancel. Here 3 by 3 will also get cancelled. So P upon P2 into 3 by 1 is 1. Therefore, new pressure is 3 times P. Hello? Hello? Hello?
हाँ सर.
हाँ, समझा है बराबर अभी 3P आया जो
हाँ
गैस वाला सम अगर आया पीवीटी डरना ही मत तीनों लाइन जैसे आइडियल गैस इक्वेशन लिखना टेक रेशियो विच एवर इज सेम एलिमिनेट बच गया वो आंसर सॉल्व
हाँ सर.
This Thursday test on KTG radiation MCQs. So Monday, Tuesday, Wednesday, at least you have to revise from the sheet first everything. We did nearly one बहुत सम किया शायद मुझे लगता है 167 के ऊपर था इसमें. Total 207 sums we did. 207 over 169 sums total we have done. Completed? Do fast.
हाँ सर कंप्लीट हो गया.
Okay. Sum number 10. A cylinder contains 2 kg of air. So mass of air 2 kg. At pressure of 10 raised to 5 Pascal, which is SI unit. If 2 kg more is pumped, it तो नया is 2 पहले से है plus 2 more, that is 4 kg is pumped into it, keeping the temperature constant. So T1 is same as T2. New pressure will become how much? See, because container is same, therefore volume will remain same. Since same container. So whenever you see same container, that means volume is same, is indirect information, indirect. फिर से गैस वाला प्रॉब्लम आया तो मैं बोलता हूँ PV is nRT. N means given weight upon molecular weight into RT. So P1 V1 upon P2 V2 is M1 upon M2 into T1 by T2. First pressure 10 raised to 5. Volume is same, cancel. Second pressure we want. First mass 2, second mass 4, temperature same also cancel. 2 2s are 4. So new pressure is 2 into 10 raised to 5 Pascal. 2 into 10 raised to 5 Pascal is option. So
हाँ सर डन.
The internal energy of perfect gas does not change during which process? How many types of process you know in gas? What is meaning of isothermal process?
Internal energy.
Meaning of isothermal process?
Delta E equal to
क्या बोल रहे हैं आप? तो थोड़ा तो पढ़ना चाहिए, ये सब केमिस्ट्री है. Isothermal process means temperature is constant. हुआ नहीं क्या केमिस्ट्री में सब?
हाँ,
बचपन से आप पढ़ रहे हैं केमिस्ट्री. Isothermal process means temperature constant. Isobaric means pressure constant.
pressure constant.
Pressure constant.
Isochoric
Volume
Volume,
constant.
volume
volume
constant.
constant. क्या हो गया आर्यन? प्रेशर आया लगता
No, sir.
है. Adiabatic means heat is constant. तो अभी देखते हैं वो लोग ने क्या पूछा है हम लोग. इंटरनल एनर्जी कौन सा प्रोसेस में कांस्टेंट होता है? इंटरनल एनर्जी डिपेंड्स अपॉन टेम्परेचर. ये मालूम रहना चाहिए, ये इंपॉर्टेंट है. ये तो प्रोसेस मालूम ही है ना. इंटरनल एनर्जी डिपेंड्स अपॉन टेम्परेचर. नाउ therefore if internal energy is to be constant, so common sense temperature must be constant. Therefore temperature is constant. Temperature constant को क्या बोलते हैं? Isothermal. Therefore process is isothermal. Is that clear? Hello? Hello?
हाँ sir.
So isothermal
हाँ, sir.
process because internal energy constant रखने के लिए temperature constant चाहिए. Temperature constant को isothermal बोलते हैं. Write everything up because हर एक point important है. Otherwise you will not remember concepts. Done?
Yes sir.
Next one. This was 110. A vessel has mass of 6 kg oxygen at pressure P and temperature 400 Kelvin. A small hole is made in the vessel so that oxygen leaks out. How much oxygen leaks out? Leaks out मतलब change in mass चाहिए हम लोग. If the final pressure is P by 2 and temperature is 300 Kelvin. फिर से वही gas related. Is the cylinder same or different in which hole is made?
Same sir.
So volume will be same or different?
Same.
Same, sir.
So the PV equals to given weight upon molecular weight RT. So P1 upon P2 is M1 upon M2 T1 by T2. First pressure P upon second P by 2. M1 is 6, M2 I don't know. Temperature 400 upon 300, 0, 0 cancel, Pt cancel. 2 will come in the numerator equals to 3 into 2 is 6. So 2 4 is 8 upon M2. Therefore M2 equals to 8 by 2. M2 equals to 4 gram. Arya? Arya? Hello Arya? Arya,
distance of a
Yes,
planet
sir.
from the
if
sun.
if
म्हणजे
M2 is
या
4,
पिरियडचा स्क्वेअर हा डायरेक्टली प्रपोर्शनल आहे. कशाशी डायरेक्टली प्रपोर्शनल आहे? द क्यूब ऑफ मीन डिस्टन्स फ्रॉम
हेलो
प्लॅनेट
सर, इधर
फ्रॉम
ना
द सन.
बहुत नॉइज है.
म्हणजे सूर्यापासून ते प्लॅनेट पर्यंत
अच्छा अच्छा,
अंतर आहे.
आपके घर पे कोई टीचर है आर्या?
क्यूब ऑफ
हाँ, मेरे
मीन
मॉम.
डिस्टेंस ऑफ अ प्लैनेट
Oh.
फ्रॉम द सन.
अच्छा अच्छा, ठीक है.
आर इज
हाँ, हाँ, ठीक है. देखो ध्यान से देखो, ये M2 is 4 gram. This M2 4 gram means mass left is 4 gram. We want mass leaked out, correct?
2 grams.
कहाँ? अभी गलती से M2 मत लिख देना. M1 was present at the start, M2 is present at the end. कितना चला गया ये पूछा है ना? So it is 6 minus 4 equals to 2 gram. This answer 2 gram. So here only chance of mistake is you may keep the answer as 4.
Done.
Okay. Others have also done. शिका हो गया?
हाँ सर.
सर आज से कॉलेज चालू हो रहा है.
अच्छा स्टार्ट करेगा. 113. The molar gas constant is same for all gas because at same temperature and pressure equal volume of gas will have same number of molecule, average kinetic energy, density. क्या लिखा है वर्ड? सेम टेम्परेचर दिखा आपको? हेलो,
हाँ सर.
सेम टेम्परेचर वर्ड दिखा क्या? सेम टेम्परेचर
नहीं है सर.
है ना? क्या लिखा है ना इधर? क्या लिखा है? मोलर
What?
गैस कांस्टेंट इज सेम फॉर ऑल गैस बिकॉज
सर
एट
आपने
सेम टेम्परेचर.
112 मिस किया.
सॉरी सॉरी सॉरी, 112. तो 113 में बोला है सेम टेम्परेचर. इफ सेम टेम्परेचर देन बिकॉज इट हैज एवरेज काइनेटिक एनर्जी सेम. टेम्परेचर सेम, एवरेज काइनेटिक एनर्जी.
हाँ सर, वो टेम्परेचर और काइनेटिक.
अभी 112 देखता हूँ. ओपन माउथ बॉटल. If it is open mouth bottle, मतलब उसका pressure is in contact with atmospheric pressure. Mouth is open, तो pressure is always atmospheric. तो इसमें दो चीज सेम है. कंटेनर सेम तो वॉल्यूम सेम, ओपन है तो प्रेशर इज सेम. सो P and V are constant. An open mouth bottle contains gas at 60 degrees Celsius. That will become 60 plus 273, which is equals to 3, 6, 7, 13, 333 Kelvin. To what temperature should the gas be heated? So what should be new temperature gas be heated? So that 1/4 of gas may leave. If 1/4 is leaving, what is left out? 3/4, na?
3/4.
3/4 left out. हो गया. What should be the temperature? फिर से वही सेम मंत्रा डायरेक्ट लिखता हूँ. P1 upon P2, V1 upon V2 is M1 upon M2, T1 upon T2. Pressure same है, volume same, cancel. Therefore T1 upon T2 is M2 by M1. M2 by M1. M2 is 3/4 M1 upon M1. M1 M1 cancel. Therefore T2 is 4 by 3 times T1, which is 4 by 3 into 333. cancel हो गया. So it is 444 Kelvin. है क्या 444 Kelvin? नहीं, Celsius में. Then minus 273. 444 minus 273 in degrees Celsius is P2. 4 minus 3 is 1. 14 minus 7 is 7. है क्या देखो ऑप्शन 171?
है सर बी.
B वाला ये आंसर है. Complete now. 112 then 113.
डन.
Okay. Next. 114. Pressure versus temperature graph is as shown. Temperature T naught, 2 T naught, P naught, 3 P naught. What the pressure, temperature versus pressure graph is given as shown in figure. Density of gas at A is rho naught. What will be density at B? A का density दिया, B का भी है तो find. Same mantra again. P, V is N, R. So P into density में convert करो. Volume is mass upon density. This is given weight upon molecular weight RT. Mass cancel. So P by rho is RT upon molecular weight. First pressure is P naught. I'm writing as P1 P2 first into rho 2 by rho 1 equals to T1 upon T2. So first pressure is P naught. Second pressure 3 times P naught. First density is rho naught. Second density V1. First temperature T naught. Second temperature 2 T naught. ये जो same है cancel कर दो. So rho 2 equals to 3 times rho naught upon 2. Okay? Hello? Hello? Hello?
हेलो हेलो.
हाँ समझ गया ये?
हाँ हाँ सर.
लिखो ठीक है.
सर वो माइक अनम्यूट से म्यूट करते तो टाइम लगता है थोड़ा.
वो टाइम लैग है ना थोड़ा आने जाने.
हाँ. डन.
115. Consider mixture of oxygen and hydrogen kept at room temperature as compared to the hydrogen molecule and oxygen molecule will hit the wall with same speed, different speed. ऐसे क्वेश्चन. टेम्परेचर सेम बोल दिया ना.
सर टेम्परेचर दिया है रूम टेम्परेचर. हाँ सिर्फ रूम टेम्परेचर दिया है.
दोनों का टेम्परेचर जो भी है वो रूम
हाँ
टेम्परेचर
सेम
है
है
जो
सर.
कांस्टेंट है.
हाँ.
that means इसका एवरेज काइनेटिक एनर्जी कांस्टेंट हो गया दोनों का. So kinetic energy of hydrogen is same as kinetic energy of oxygen, meaning half into mass of hydrogen. RMS velocity of hydrogen is equals to half into mass of oxygen into RMS velocity of oxygen. half cancel. अभी mass of hydrogen RMS velocity मतलब 3 times kT by m बराबर, और इसका भी आएगा 3 kT by m इन रूट स्क्वायर कर दिया तो रूट कैंसल, तो ये मास कैंसल हो गया, सब कैंसल हो गया. So what you are getting now with same speed ना.
सर हमने स्मॉलर या ग्रेटर पूछा है.
एक मिनट रुको. Average temperature is constant. Since temperature is constant, 1.5. Therefore, half of mass into RMS speed is constant. Total will be same, लेकिन m and speed are inversely proportional. So C is inversely proportional to m. I can write. Mass of hydrogen is less than mass of oxygen. So C of hydrogen will be greater than C of oxygen. C of hydrogen molecule and oxygen molecule will hit the ball, as compared to hydrogen molecule, oxygen will hit with smaller speed. Hydrogen ज़्यादा.
Yes, sir, done.
आज के लिए इतना. अभी 2 ही सम रह गया, वो मैं नेक्स्ट लेक्चर में बताते हैं. Then we'll start with thermodynamics. You have test on MCQs of KTG radiation on Thursday. Okay. Next we are meeting on Tuesday morning, same lecture, same class, same time.
Tuesday, sir.
Wednesday.
Yes, sir. Thank you, sir. Bye, sir.
Thank you. Bye.